Section 9.4 is graphing sine and cosine, and there's two parent functions for this section. One is y equals sine of x, one is y equals cosine of x. I'll post another video that goes into greater detail on how to find the specific points from the parent function, but I wanted to make this video a little bit more short and to the point. So basically every single sine and cosine graph will repeat over and over again. You can see it's kind of like a cyclical motion. It's going up and down and up and down. That'll continue on forever, left and right. It'll never get any higher or any lower. You can see on my graphs, the x-axis is labeled from 0 to 2 pi on both of them, and that's because the points come from points on the unit circle, and one full rotation on the unit circle goes from 0 to 2 pi. So that's basically what we're graphing, is we're graphing one rotation around the unit circle. If you look at the individual tick marks on the x-axis, like the 0, pi over 2, pi, 3 pi over 2, and 2 pi, those are all the quarter markers on the unit circle. So if I go like 1/4 of the way around the unit circle, that's pi over 2. Halfway around the unit circle is pi. 3/4 of the way around is 3 pi over 2. And then all the way around is 2 pi. And then on the y-axis, you can see it goes up from 1 and then down to -1. That's because those are the highest basically output values that you can get from the unit circle, because the unit circle has a radius of 1, so there's never going to be any points above that. So all the other like little in-between points that are on the unit circle are like 1/2, 3 pi over 2, root 2 over 2, all numbers between 0 and 1. So main things I want to point out is that these graphs will always have a midline, and then you want to have 5 points on your graph. We're basically just graphing one rotation around the unit circle. So on the parent function for y equals sine of x, when you graph in, we'll do these examples together as well. The main things I want to point out is that you have 1, 2, 3 points on the midline, and they happen at the beginning of the cycle. That's just one repeating portion of the graph. So at the beginning of the cycle, the end of the cycle, and then right there in the middle. And every single cycle we're going to kind of separate into fourths. So beginning, middle, end. And then every sine graph will also have a maximum and a minimum. Unless there's some sort of reflection that flips it up, we're going to go up to the maximum first, or if we have a reflection that flips it upside down. If we don't have that, we're going to go up to the maximum first, and then we'll cross down through the midline right here, and then down to the minimum down here. And our graphs are going to look really similar to that. We're just going to apply like different transformations. We may like stretch it, make it kind of get taller, shift it left, right, up or down, and so on, just kind of like we have all year. And then for cosine, same thing, 5 points. For cosine though, instead of starting at a midline, you start at a maximum. Again, same thing unless there's like a reflection. It also ends at a maximum. So cosine starts at the high point, ends at the high point, and we'll get into like how to find the high points later on. And then halfway through the cycle, it's at a minimum. So it's low point. And then the last 2 points that you need to place are on the midline. So right here, right here. And then same thing, this has been separated into fourths. It's just 0 to 2 pi and then cut into fourths. So like this is 1/4 of the way right here, 1/4 right here, 1/4 right here, 1/4 right here. Okay, and then the formulas that have all the different variables put into them for transformations are down below. So for sine, it's y equals a sine b of x minus h plus k. And then for cosine, it's basically the same thing, just we swap out sine for cosine. So all of the other variables are in the same place. B is new, but a, h, and k all pretty much mean the same thing as they have all year. So A is, it's still stretch, and if it's negative, a reflection, but with sine and cosine graphs, we use a word called amplitude. H is still a horizontal translation. There's a new word for that with sine and cosine as well. And then K is a vertical translation. Okay, and then definition starting from the top. So you've heard me use the word cycle. A cycle is the shortest repeating portion of the graph. So these graphs up above, they'll go on forever, left and right. They'll just keep repeating itself. These are each one cycle, one repeating portion before it starts to repeat itself. And then this next part, the period, this is really important. So the period is the horizontal length of each cycle, basically how long it takes for it to start to repeat itself. You can find the period by finding 2 pi over b, or 2 pi divided by b. So if we look back up at the parent functions, if we're starting, say right here, we go up, come down, go back up, and then it starts to repeat itself right here. So that kind of section that I put in green, that's from 0 to 2 pi. That's one repeating portion, so the length of the period is 2 pi. And that's standard for the parent function. Depending on what b is, though, that can change the period, and that just changes the way that you set up your graph and set up the x-axis. Okay, amplitude, the next one is half the difference between the max and the min. It's also, if you're looking at an equation, it's the number out in front. Amplitude is a distance, though, so it's not just a, it's the absolute value of a. It's always a positive number because it's a distance. And then midline, it's a horizontal line that cuts the graph in half. Up here, it was like that kind of magenta E line. It starts at y equals 0. The only thing that would change it if there was a vertical translation, if it was moving it up and down. So it's always given by y equals k, because k is our vertical translation. And then the last one, a phase shift, it's just a fancy word for like a horizontal translation for sine and cosine graphs. It's given by h. Okay, example 1, find the amplitude and period and then sketch a graph of the function. So amplitude, I'm going to go back up here for a second, is always given by a, which is out in front of it's whatever number is being multiplied by the sine or cosine. So for example 1a, it's f of x equals 3 sine 2x. So a would be 3, and then to find the period, we have to figure out what b is. So b is always the number that's between like sine or cosine and your variable. So typically it's x, sometimes you'll see theta though. So in this case, b is 2. So for finding the amplitude, it's just whatever the absolute value of a is. So in this case, a is 3, our amplitude is 3. That's going to be the distance that we go like above our midline and then below our midline. And then for the period, though, I'm going to go back up here. There was a little formula we had to use to find the period. It's not just b, it's 2 pi divided by b. So you have to find b to find the period, but that's not like the end-all be-all. So period is 2 pi over b, and then we just found that b was 2. So we'll do 2 pi over 2. And then 2 divided by 2, that cancels out, so I'm just left with pi. So the period for the parent functions, like we set up here, it's just one repeating portion. So we go from like 0 to 2 pi. Ours is going to be cut in half, but our graph is still essentially going to look the same. We don't really have to shrink our graph, like we don't have to make it more narrow. We just have to change the way that we scale the x-axis. So you don't really want to scale things until after you find the amplitude and the period. Okay, so our period is 2 pi, just pi. So when we scale our x-axis, I still want to kind of put my same points. I still want to cut it up into fourths like the parent functions, but I'm not going from 0 to 2 pi anymore. I'm going from 0 to pi. So I'll put my 0, and then I'm going to make my furthest most point pi. And then now I just have to cut the section between 0 and pi into fourths. So I'm going to put a halfway point. That's pi over 2. That just means like 1/2 pi. And then I'll put a halfway point between like 0 and pi over 2. So right here, that's like 1/4 of pi, so pi over 4. And then I'll put one halfway between pi over 2 and pi, so like the 3/4 mark. So 3/4 would be like 3 pi over 4. Okay, and then these, for example 1, these graphs don't have any horizontal or vertical translations, so that means that the midline is still at y equals 0. I'm just going to go ahead and put that on my graph right now. And then that helps me figure out how to scale my y-axis. So if my amplitude is 3, the amplitude is basically the distance that the graph is going to go from the midline to its max or to its minimum. So if we go back up to the parent function really quick, this distance right here is the amplitude. And then same with this distance right here. So for the parent function, the amplitude is just 1. So the distance we're going from the midline to the max is 1, and then down to the minimum is also 1. So on my function, though, the amplitude is 3. So the distance I'm going to go from the midline up to my max is going to be 3, or down to my minimum is going to be down 3. So I have to scale my y-axis by 3. Okay, so now I'm ready to put my points. So this is a sine graph. So sine graphs start at the midline. So at 0, we'll put a point at the midline. And then they end at the midline as well. So not end, but the end of the cycle. So the end of my cycle is pi. So I'm going to put a point at pi in the midline. And then there's one more point on the midline. It happens halfway through. So at my halfway point at pi over 2, I'll put one on the midline as well. And then the last 2 points I need to place for sine are the maximum and the minimum. So there's no reflection or anything like that. So at my quarter of the way mark, I'm going to go up to a maximum, which is going to be 1, 2, 3 above the midline. So right here at pi over 4 and 3. And then my last point I need to place is my minimum, which is going to be 3 below the midline. It's going to happen 3/4 of the way through the cycle. So at 3 pi over 4. So 3 pi over 4 and then negative 3 right here. And then I just need to connect them in that kind of curving shape. Okay, not the prettiest, but we got the points, and that's the most important thing. Okay, so B is g of x equals 2 cosine pi of x. So same thing, we want to figure out what the amplitude is, figure out what the period is. So for our amplitude, A is the number that's out in front. In this case, A is just positive 2, so amplitude is going to be positive 2 as well. And then for the period, we have to figure out what B is, which B is the number that comes between cosine and x. In this case, it's pi. I know pi looks like it is a symbol, but it's also a number. So our B is going to be pi, and then we have to take that and plug it into the formula for period, which is 2 pi over B. So we're going to do 2 pi over pi, and then pi divided by pi, those cancel out, so we're just left with 2. So on the parent function, our period is 2 pi. On our first example we did, our period was just pi. In this one, our period is just 2, which is fine. It works the same exact way. It's just when we scale our x-axis, we're not going to have little pi's in our symbol. So for example, 1, we had pi, 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 pi. We won't have that with this one because our period isn't in terms of pi. So same thing, we're going to start at 0, 0, and then our period is 2, so we're going to make our furthest point 2. And then I have to take 0 to 2, and I have to break that down into fourths. So a halfway point, 1, and then halfway between 0 and 1 is 1/2. And then halfway between 1 and 2 is 1.5 or 3/2. I'm not really picky with how you scale that, as long as it's some correct version. So if you want to do 0.5 and 1.5, that's fine also. Okay, and then I'm going to put the midline down. We don't have any vertical translations, so our midline is just at y equals 0. And then our amplitude is 2, so that's going to be the highest that we go above the midline. So for our y-axis, we need to scale by 2. Okay, so this one is cosine. So for a cosine graph, instead of starting at the midline, we start at a maximum. Our amplitude is 2, so our maximum is going to be 2 above the midline. So at 0, 2, that'll be our first point. And then our cosine graphs also end, or the cycle ends at a maximum as well. So at the end of the cycle at 2, we'll be at a maximum again, so 2, 2 over here. And then halfway through the cycle, cosine will be at a low point at a minimum, which would be 2 below the midline. So halfway through the cycle is at 1 and then negative 2. And then the last 2 points that we need to place are the ones exactly on the midline. So a quarter of the way through and then 3/4 of the way through. So at 1/2, 0 or 1/2 on the midline, and then 3/2 on the midline as well. And then from there, just connect them. And then, like I said, these graphs will like continue on forever and ever and ever. Technically, they're honestly almost the same graph because they come from the same set of points on the unit circle. The only thing that's really different is where each cycle is starting, as far as like starting at a maximum or starting at a midline. Okay, so example 2, find the amplitude, period, phase shift, and midline, and then sketch a graph of the function. So this one will have a little bit more transformations. They won't have all of them on every single problem, but there's more to work with on each one. So amplitude, still the number that gets multiplied out in front of sine or cosine. Oops. So in this case, our amplitude is 3. I'm just going to go through and label each different variable. B is always the number that's in between sine and like x, or sine and theta in some cases. H, if there was an h, would be a number added or subtracted from x, but there would need to be parentheses. So if you look down here at like example B, it has x minus pi in parentheses. That would be h. Since the 2 is not inside parentheses, that's k. Okay, so absolute value of A is our amplitude. So our amplitude is 3. Period is 2 pi over B. So we'll take 1/2, which was our B, and plug it in there. So 2 pi over 1/2. Usually instead of dividing by fractions, we change it to multiply by the reciprocal. So we can do 2 pi, and then instead of divided by 1/2, do times 2, or times 2 over 1. So ends up simplifying to 4 pi. Which is like probably the easiest one to kind of set up, which is nice. And then for a phase shift, that's h. So phase shift is h. That's your horizontal translation. It's just like a fancy word for it. There was no h, so you can just write none. And then for the midline, there was a vertical translation up 2 because k was 2. So our midline is y equals 2. And before you kind of draw your x and y axis, think about like the information that you have. So my midline is 2. That's like pushing everything up 2. And then my amplitude is going to be up 3 from there. So that's why I set up my graph with like a more of a positive on the y-axis, because I'm starting at 2 and going up 3. So I'd be going up to 5. Versus if I start at 2 and then I only have to go down 3, I only need to go down to -1. So just stuff to consider so you can kind of like save space on your paper, or draw your graph like a little bit more precisely. Okay, so period is 4 pi. So we're going to go from 0 to 4 pi, and then we're going to separate that into fourths, which is easy because now we can just do like 1 pi, 2 pi, 3 pi, 4 pi. So the halfway point is 2 pi. Halfway between 0 and 2 pi is pi. Halfway between 2 pi and 4 pi is 3 pi. And then our midline is y equals 2. I'm going to go ahead and scale the y-axis. We're going to go all the way up to 5. And we just need to go down to -1 on the negative side. So we'll add in our midline. That's at y equals 2. Midline is always a horizontal line. And then it's like really important that you draw it first. I wouldn't skip it or try to like just estimate your graph without it. I would always draw it in there. Okay, so we're ready to draw our points now. So this one is it's a sine graph. So for a sine, we start at the midline. So at 0, we'll have a point on the midline. The cycle ends on the midline. So at 4 pi, be on the midline as well. And then halfway through the cycle, we'll be on the midline again. So for sine, like 1, 2, 3, your first 3 points are always on the midline. It's start, finish, and then middle. And then the last couple points we need to place are the maximum, which in this case, our amplitude is 3. So our maximum is going to be like 1, 2, 3 above the midline. And then the minimum is going to be 1, 2, 3 below the midline. Unless there's a reflection, the maximum will happen first. So at like the quarter of the way mark. So for this one, it's at pi and then 5 up there. And then the minimum will happen at the 3/4 of the way mark. So this time it's at 3 pi and then -1 down there. And then from there we can connect them. And then that's it. Always 5 points. Okay, so for b, it's g of x equals 5 cosine of x minus pi. So same thing, go through, figure out what each different variable is. So in this case, a is 5. There's no number like in between the cosine and the x, so that would mean b is 1. So if you don't see a number there, b is 1. That just actually means like there's no change from the parent function, so our period is technically going to be 2 pi. And then because that pi is inside the parentheses like with the x, or added or subtracted from the x, that's our h. And it's the same thing as it has been all year, where inside this is like x minus h. So h would be positive pi, and we'd be shifting like pi to the right. Okay, so amplitude is the absolute value of a, so 5. Period is 2 pi over b, which b was 1, so it's going to be just 2 pi. Or 2 pi over 1, which still simplifies to 2 pi. And then the phase shift, h was pi. So our phase shift is pi. Or if you want to say pi to the right, just to remind yourself, you can do that. And then there was no like number added over here, so that just means there's no vertical translation, so the midline is still at y equals 0. That's where it starts at. Okay, so we'll go ahead and scale the x-axis. So we'll go from 0, and then our period is 2 pi. I'm not going to go all the way to the end, though, and we'll talk about y in a second. So 0 to 2 pi. And then before you worry about the phase shift, that's kind of why we added the extra, or left the extra room at the end, I would break your cycle down into fourths first, and then worry about adding extra marks for the phase shift. So I'm going to go from 0 to 2 pi. And then halfway between there is pi. Halfway between 0 and pi is pi over 2. And then the 3/4 mark would be 3 pi over 2. So those are the same marks as the parent function because the period was the same. It was still 2 pi. And then I know, though, that I'm going to have to shift everything pi to the right. So I'm going to have to add like an additional pi to the end of my x-axis. So it stopped originally at 2 pi, so I'm going to have to go all the way to 3 pi. I just want to pay attention, though, like to how big on my scaling like pi actually is. So this distance is what took us from pi to 2 pi, so it should be the same distance from 2 pi to 3 pi. So it should end up like all the way over here. I don't know how accurate that is, but 3 pi over here. And then I just want to go ahead and add like that middle tick mark because there was a mark every half pi, not just 1 pi. So we'll add it in here. It's halfway between 2 and 3, so it's like 2.5, which if we're talking like improper fractions would be 5 pi over 2. I know sometimes that gets tricky, though, so I'm not going to be like super picky if you mess something up there. If you prefer to put it as a decimal, that's fine also. I know sometimes it's just more comfortable. Okay, so this next part is entirely up to you. Actually, I'm going to add the midline first. So midline is at y equals 0. And then this next part is entirely up to you. If you want to just graph the like original function without the phase shift and then just count them over, or if you want to do the phase shift all at once, I'm going to put the original points there with the new amplitude and stuff, and then just move them all pi to the right, just so we can kind of see the in-between phase. So this is cosine. Oops, I need to scale my y-axis, but amplitude is 5, so we'll go up to 5, and then down to -5. And then this is a cosine graph, so we'll start at a maximum. I'm not going to worry about the phase shift yet, so this is the graph without the phase shift. So we'll start at a maximum, so at 0, 5, and then we end at a maximum, so at the end of the period, which is 2 pi. So 2 pi and then 5 up here, and then halfway through the cycle, we should be at a minimum, which would be 5 below the midline. So at 5, we're at pi, and then -5 down here. And then the other 2 points are just going to be right on the midline. So the quarter of the way mark, that's pi over 2, and then 3 pi over 2 is on the midline as well. So those are, basically it's the cosine, but just stretched with the new amplitude. And then now I'm going to move each of these points just pi to the right. So if I go from, this is going from 0 to pi, my new point would be right here. and then pi over 2. Basically, moving pi to the right is moving everything 2 tick marks. So this would move like 1, 2 right here. This would move 1, 2 right here. This one moves 1, 2 right here. And then this one moves 1, 2 over to 3 pi. And then just keep in mind, like, you should end at 3 pi because it originally ended at 2 pi and you're moving 1 more pi to the right. And then from there you can connect your points. And like I said, it's up to you if you want to put the original one and then move them, or just move them all at once. Sorry, that got a little crazy at the end. Okay, and then last one. So for C, it's y equals -3 sine 1/2 of x minus pi over 2. So we'll go through, figure out what each variable is. So A is -3. We know that the amplitude is the absolute value of A, though, so we'll think about that. For B, it's the number that's in between sine and x, so it's 1/2. And then this pi over 2 is inside the parentheses, so that's our h. And then same thing, this is like x minus h inside here. So h is positive pi over 2, so we're going to the right as well. Okay, so for our amplitude is the absolute value of A, so it's 3, but I'm going to add it's 3 with a reflection. And it's going to be a reflection over the x-axis. It's like flipping upside down, basically. And then for the period, it's 2 pi over B, which was 1/2. We already did the 2 pi over 1/2. That was up here, like for A. So we'll end up getting the same thing. We'll get 4 pi. And then the phase shift, h was pi over 2, so we're going to go pi over 2 to the right. And then same thing, there's nothing added to the end of it, so the midline is still at y equals 0. Okay, so we'll set up our x-axis according to the period, and then we'll start to worry about the phase shift after. I'm going to leave a little bit of space at the end of it, though, just so we have room for the extra pi over 2. So we're going from 0 to 4 pi, and then we'll separate that into fourths. So halfway is 2 pi, a quarter of the way is pi, and then halfway between 2 pi and 4 pi is 3 pi. And then this one's a little bit tricky, and for something like this, I'm not going to expect you to go in and add every single little halfway increment. This one's tricky because the phase shift is pi over 2, which is not like a full, we don't have the pi over 2 scaling already on our x-axis. So pi over 2 would technically be halfway between 0 and pi, so it's just a little halfway mark. So that's all I want us to add, is just add a little halfway mark. I'm going to do it in a different color. A little halfway mark right here, right here, right here, right here, and right here. And that's just how far we're going to shift everything over. So instead of going from 0 to 4 pi, we're going to go from half pi to 4.5 pi. And then for our amplitude, the amplitude is 3. So we'll go up to +3 and then down to -3. And then the midline is still at y equals 0, so we'll add that in. And then this one's a sine graph. So for sine, we start, and then there's a middle point on the midline. So I'm going to put, I think, all of the... we'll just do we'll do the phase shift together in one step instead of 2 steps like last time. So for sine, we're starting at the midline, but instead of starting at 0, I'm starting at this halfway mark. And then we're ending at the midline. And instead of ending at 4 pi, I'm starting at this I'm ending at that 4.5 pi mark. And then my typical middle would be 2, but I'm at 2.5 for this one. And you can also just count what's the halfway point between here and here. It's right here. Okay, so we have our 3 midline points for sine, and then sine, the last one we need to place is the maximum and the minimum. This one we have the reflection. So instead of going up to the maximum first, down to the minimum next, it's going to be reversed. So we're going to go down to the minimum first, and that's going to be the quarter of the way mark between between our entire period, I guess, so 1/2 pi and 4.5 pi. I think the easiest way is just to look at, like, where you know it should be, and then scooch everything, like, right by that halfway mark after. So our minimum is going to be 3 below the midline. It should happen right here, and then down 1, 2, 3 right there. And then the last one we need to place is the maximum, which that's at the 3/4 mark, so it should be happening right here, and then up to 3 to the maximum up here. And then from there we can connect our points. And same thing here, if you'd rather if you would rather draw the original graph first, like without the phase shift, and then just count them over by like half after that, it's totally fine. It really just comes down to personal preference.